Chapter 4 is the law of sines, cosines, and vectors. We'll start here with our objectives to use the law of sines to solve oblique triangles. Use the law of sines to solve triangles in the ambiguous case. Find the area of an oblique using the sine function, and solve applied problems using the law of sines. First of all, an oblique triangle is one that does not contain a right angle. An oblique triangle has either 3 acute angles or 2 acute angles and 1 obtuse. These are examples of an oblique triangle. The relationships among the sides of the angles of right triangles defined by the trig functions are not valid for oblique triangles. We do, however, have the law of sines, and it says that if A, B, and C, the angles, are measures of the angles of a triangle, and lowercase a, lowercase b, and lowercase c are the lengths of the sides, then then the following ratios are equal. The ratio of the length of the side of any triangle to the sine of the angle opposite that side is the same for all 3 sides. So we can use this to help solve oblique triangles. Solving an oblique triangle means finding the lengths of its sides and the measure of its angles. The law of sines can be used to solve a triangle in which 1 side and 2 angles are known. The 3 measurements can be abbreviated to side angle angle or angle side angle, depending on the order of the items that you know the values of. First example that we're given here says solve the triangle with angle A 64 degrees, angle C 82 degrees, and C 14 centimeters. Round the lengths of the sides to the nearest tenth. Here's our picture. A is 64, C is 82. We know that 3 angles have to add up to be 180. We use that to determine that B is 34 degrees. We continue on with our ratios. Now we're using A over sine A and C over sine C because those were items that we did not calculate. We calculated B. We didn't make a mistake, but we're better off to use numbers they give us than we are to use calculated. So we have A over sine A equals C over sine C. So A would equal, if we used cross products, C times the sine of A over C. We plug in 14 for C, 64 degrees for A, and 82 degrees for C. Do our calculation and we get 12.7 centimeters. So we've calculated so far that B is 34 degrees. We've calculated that A is 12.7. The next thing we have to do is we have to find a B, which is 7.4. Now we have no option here. We have to use what we came up with for angle B, which is 34 degrees. We know that B over sine B is equal to C over sine C. We know if we use cross products that B will equal C times the sine of B over the sine of C. Plug our values in and we get 7.4 centimeters. Okay, next triangle. To solve this triangle, ABC, if A is 40, C is 22.5, and B is 12. Round to the nearest tenth. First, we find our missing angle. It is 117.5 degrees. And then we set up our ratios. B over sine B is equal to A over sine A. If we cross multiply, A will equal B times the sine of A over the sine of B, which is 12 times the sine of 40 over the sine of 117.5, which is 8.7. So we know that side A is 8.7. So we're moving right along. We found this. We're looking for C. B over sine B is equal to C over sine C. Cross products will tell me that, wrong way this time. Cross products will tell me that C is equal to B times the sine of C over the sine of B. Plug in and you'll get 5.2. These are very easy to use. Now, the ambiguous case. If we're given 2 sides and an angle opposite of one of the 2 sides, the given information may result in 1 triangle, 2 triangles, or no triangle at all. Side-side angle is known as the ambiguous case when using the law of sines because the given information may result in one, two, or no triangle at all. Okay, things that can happen in the ambiguous case. Consider a triangle in which A, B, and capital A are given. The information may result in one triangle if A is greater than H and A is greater than B. We get one triangle. We could have one right triangle if we find that A is equal to H and is just the right, A equals H and is just the right length to form a right triangle. If A is less than H and is not long enough to form a triangle, then we have no triangle at all. If A is greater than H and A is less than B, then we have two possibilities here. Let's see what happens with our first example. It says solve the triangle if A is 50, lowercase a is 10, and B is 20. So we use this law of sines. We plug in A times the sine of B is equal to B times the sine of A. We solve for sine B, and we get sine B equals B times the sine of A over A. Plug your values in. We get 1.53 for the sine of B. Well, there's no way that we can have a sine value greater than 1. So when that happens, we know there is no triangle. Next example, solve the triangle if A is 35, lowercase a is 12, and B is 16. Round to the nearest tenth, angle measures to the nearest degree. So we set this up. A over sine A equals B over sine B. We arrange our formula so that it suits us, and we get the sine of B equals B times the sine of A over A. We get 0.7648. Do sine inverse on your calculator and you get 50 degrees. There are two angles between 0 and 180 for which the sine of B is equal to this. One's 50, the other is 130. So if we use 50, A and B, A being 35, B being 50, they add up to be 85 degrees. And we could find a C for that. If we use the next one, which is A is 35 and B is 130, we could find a C to match up with this one. So there are two possible solutions here. A plus B could be less than 180, and both of them are less than 180. So we could find a C to go with that. In this case, C would be, let me grab a calculator. C could be 95. In the next case, C could be 15. So we've got two possible options for this example. Here we are, 95, 15. Solve triangle. If you're using B1 and C for 95, and we set up and we solve, and we find C1 to be 20.8. We're using B2 and we solve, we find the other option to be 5.4. There are two triangles that are possible for this example. Okay, area. The area of an oblique triangle is 1/2 of BC times sine A, 1/2 AB times sine C, or 1/2 AC times sine B. So whatever two sides you're using, you use the other angle, and you can use any part of that you like. So find the area of the triangle having two side lengths of 8 and 12 and an included angle of 135. So we know that this is lowercase b, this is lowercase a, and angle C is 135. Plug that in, and we get our area to be 34 square meters. Two fire lookout stations are 13 miles apart, with Station B at 49, Station B directly east of A. Both stations spot a fire. The bearing of the fire from A is north 35 degrees east, The bearing from B is north 49 degrees west. How far to the nearest tenth of a mile is the fire from station B? So we're trying to find the distance from B to C. A is 90 minus 35, so this is 55 degrees. B is 90 minus 49, so it is 41 degrees. So I can figure that angle C is 84 degrees. Okay. So here's what I have. I have 55, 41, and 84. And I'm looking for this distance here, which is lowercase a. And I know that this is 13. So A over sine A is equal to C over sine C. So we plug that in. We find that it is approximately 11. Good luck on lesson 4.